Today we're going to look at section 5 of chapter 4, which deals with isosceles and equilateral triangles. Okay? You should be familiar with what those triangles are. Today we're going to learn some properties of those isosceles and equilateral triangles that we can then use to apply to these congruent triangles. So we have a theorem called the isosceles triangle theorem that says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so you have that theorem in your notebook. Below that it says to draw an example. Okay? The example that I want you to draw is this triangle from the then part, okay, with the inclusion then of some arrows, because we're starting out in this theorem being given that the two sides are congruent. So when the two sides are congruent, then we know that those opposite angles are congruent.
Wait, we need to draw those arrows?
So you need to draw those arrows. Okay. Because our theorem tells us that if two sides are congruent, then we can mark the opposite angles to be congruent. So the sides are given, we would be marking in the angles because of this isosceles triangle theorem. Okay? Because it's an isosceles triangle when two sides are congruent. So if two sides are congruent, we know their opposite angles are congruent. The other theorem is the converse of this isosceles triangle theorem, which just means that it goes the other direction. So this time, if we know that two angles of a triangle are congruent, then we know that their opposite sides are congruent. So we are being given the two congruent angles, which means we can then mark the two congruent sides. So that's our isosceles triangle theorem and the converse of that isosceles triangle theorem, just meaning it works both ways. So if we have two sides, we can mark the angles. If we have two angles, we can mark their opposite sides. Something else that we want to think about, and this is not a particular page in your interactive notebook, okay, but is something that you will want to write down on this isosceles triangle page somewhere. You have, depending on how you glued that page in, you've got room to write, because this does apply to isosceles triangles. Okay. This theorem says if a line bisects the vertex angle of an isosceles triangle, then the line is also perpendicular bisector of the base. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base.
Do you write?
Yes, I said you should be writing this on your isosceles triangle page, because this is important information that you will need to apply. So, again, this applies to an isosceles triangle. Okay? It applies to an isosceles triangle. When I look at my diagram, I know I have an isosceles triangle because I have two sides that are congruent. then I have this vertical angle, vertex angle that is being bisected. So angle C is that vertex angle. Okay? That angle is being bisected. So cut into two equal parts. Because it's bisecting that vertex angle C, it is also bisecting the base, that bottom side. So that's cut that into two equal parts. And it's also perpendicular, which means we have right angles. So that bisector then is actually cutting that isosceles triangle into two congruent triangles. Okay? Because if we think about what else we know, because it's an isosceles triangle, if those two sides were congruent, their opposite angles would be congruent. We also have that shared side now going down the center. So I've marked all 6 pieces of those two smaller triangles. I have all 3 pairs of sides that I know to be congruent. I have all 3 pairs of angles that I know to be congruent. So when we have an isosceles triangle, okay, an isosceles triangle can be split down the center to give us 2 congruent triangles. That is what that theorem is showing us. So we can split it right down the middle when we have an isosceles triangle and get 2 congruent triangles. Equilateral triangle, we have 2 corollaries. They're on the next page in your interactive notebook, which again is kind of applying what we learned about the isosceles triangles, because an equilateral triangle is a special kind of isosceles triangle, okay? Because it does have 2 or more sides congruent. All 3 sides are congruent in the equilateral triangle. So it says that a triangle is equilateral. Okay? Equilateral means all the sides are congruent if and only if it is equiangular, which means all of the angles are congruent. So equilateral means the sides are congruent. Equiangular means the angles are congruent.
Should we draw those?
Okay? Yes, so you should draw those. For this piece, you're drawing these pictures. Okay? Set up just like your page in your book. Because again, it works both ways. If we're given that the sides are congruent, that it's equilateral, then it's also equiangular. We go opposite angles, we know all the angles are the same. If we're given that it's equiangular, we know that it's equilateral. All 3 sides are the same. So just like with isosceles, only equilateral is all 3 sides, all 3 angles. The second corollary says each angle of an equilateral triangle measures 60 degrees. That is something you have heard before, something very easy to figure out because we know 3 angles in a triangle add up to 180. If they all 3 are the same measure, 180 divided by 3 gives us that 60. So, quick lesson on isosceles and equilateral triangles. If it's an isosceles triangle, we know 2 sides are congruent. We know the opposite angles are congruent. Also works the other way. If 2 angles are congruent, their opposite sides are congruent. With an equilateral triangle, it works the same way, but with all 3 sides. So if we know all 3 sides, we can then mark all 3 angles. Or if we know all 3 angles, we can mark all 3 sides. Every angle in an equilateral triangle has a measure of 60 degrees.